Hello, my name is Jim. I am the director of the CaYPT Organizing Committee. In this video, I will be telling you everything you need to know about being a juror in the CaYPT. Although this video is made for jurors, if you're a student, you can also watch this video to get a sense of how your team will be graded during the tournament. First, I'll be giving a quick summary of the tournament structure. The Canadian Young Physicists Tournament, or the CaYPT, is a high school physics competition aimed at introducing students to scientific research. Unlike other physics competitions, the CaYPT presents students with 10 open-ended problems inspired by everyday phenomena. Students compete in teams of 3 to 5. They are expected to conduct original research on the 10 problems. In the CaYPT, teams participate in physics matches, during which they discuss their solutions to the problems in front of the jury. Teams are then graded based on their performance. The CaYPT runs for 2 consecutive Saturdays. During the 2 days, 5 selective physics matches and 1 final physics match are held. All teams compete in all 5 selective physics matches, and 3 teams with the highest cumulative selective physics match scores compete in the final physics match. Jurors have the option of judging in units of half days. Each selective physics match is approximately 2 hours long, and the final physics match is 3 hours long. In the CaYPT, teams play one of 3 roles: the reporter, the opponent, or the reviewer. The reporter presents the solution to one of the 10 problems on the request of the opponent and defends their stance during every physics match. The opponent criticizes the reporter's solution and initiates a scientific discussion. The reviewer examines the discussion between the reporter and the opponent and comments on their performance in place of a peer reviewer. In the selective physics matches, teams alternate between reporter and opponent, and in the final physics match, teams alternate between the reporter, the opponent, and the reviewer roles. Each selective physics match has 2 stages. In stage 1, Team A is the reporter and Team B is the opponent. In stage 2, the roles switch. In the final physics match, 3 teams rotate in a similar way. During each stage, the opposition team first challenges the reporting team on one of the CaYPT problems. The reporting team can choose to either accept or to reject the problem. If one team rejects too many problems, there will be a score penalty. If the reporting team accepts, one member of the reporting team will give a presentation of no longer than 12 minutes. One member from the opposition team then questions the reporter for 2 minutes. The opponent then gives a short presentation about the report, stating the merits and possible shortcomings. Then the opponent invites the reporter on stage for a 10-minute discussion. The opponent then summarizes the discussion in 1 minute, and the reporter gives a 2-minute concluding remark. Jurors are then given a chance to question the teams. Finally, jurors complete a score sheet and announces their final scores. This process then repeats in stage 2, and after the conclusion of both stages, one of the 5 selective physics match is completed. For the final physics match, the reporter begins a 12-minute report. The opponent then questions the reporter for 2 minutes. The opponent then takes the stage and gives his or her short presentation. Then the reporter and the opponent have a 10-minute discussion. After that, the opponent concludes the discussion. The reviewer then questions both the reporter and the opponent for 3 minutes. The reviewer then gives his or her review. Finally, the reporter gives a concluding remark and all 3 answers jury questions. Now that we're familiar with the structure of the tournament, we're ready to take a look at the problems of the CaYPT. The problems of the CaYPT are selected from the problems of the International Young Physicists Tournament, or the IYPT. Out of the 17 IYPT problems, 10 are selected as the CaYPT problems. The problems cover a range of topics, including classical mechanics, electricity and magnetism, thermodynamics, optics, and fluid dynamics. Classical mechanics constitutes the largest proportion of problems since it is best aligned with the high school physics curriculum. The CaYPT organizing committee selects the problems using 3 criteria. We want the problems to be viable, accessible, and engaging. The CaYPT problems and the corresponding phenomenon should allow for conclusive results. They can be tested with easily obtainable material and equipment, and will spark students' curiosities. The list of problems can be found at the CaYPT website. We have also filmed the video demonstrations to serve as a reference for the students, the teachers, and the jurors. These can be found on our YouTube channel. In fact, the footage that you have seen for the past minute are all from our YouTube channel. The CaYPT has a particular set of expectations for the students. Students are expected to develop their own theoretical model to describe the system of interest and conduct experiment for verification. During the tournament, students should present their work on PowerPoint slides, and the presentation should be organized in the format of a report with a clear introduction, theoretical model, experimental setup, data with graphs, and finally a conclusion. This is of course ideal. In reality, the reports will range in quality and complexity. The inexperienced students might only have a qualitative explanation of the phenomenon and be capable of making a simple device with limited ability to vary key parameters. The more experienced teams could contain exceptional members whose knowledge is a couple of years above the high school curriculum expectations. Keep in mind that although the tournament attracts many exceptional students, the physics that high school students know are fundamentally limited by their mathematical knowledge. When giving scores, it is important to acknowledge great physics while giving the less experienced students the encouragements they deserve. Now we're ready to talk about the most important part of this video, the score sheet. The CaYPT score sheet is adapted from the international tournament score sheet. We keep our score sheet updated with respect to the international version. The main score sheet looks like a rubric. At the top of the score sheet, we have the section for identification information. In this section, you fill in the physics match number, 1 to 5 or final, the stage number, 1 to 2 for selective physics matches, and 1 to 3 for the final physics match. The room, A to H, and the problem number, A to J. You also need to write your name and the name of the reporter, the opponent, and the reviewer. The room volunteer will ask the students to write their name on the blackboard of the physics match room. After you fill out the remaining sections of the score sheet, we would ask you to sign your name on the score sheet. The grading portion of the score sheet is divided into 3 segments, 1 for the reporter, 1 for the opponent, and 1 for the reviewer. We will indicate the portion of the score sheet that we are zoomed into for the rest of the video. Each segment is organized by time flow. Earlier events are on the left-hand side, and later events are at the right. This whole section is called a segment. Inside a segment, there are several parts of performance. These are the different phases within a stage of a physics match. These are called the entities. It is essentially what you are looking for during a physics match. Below, there are several responses that you can match to the student performances. It might seem a little messy at first, but after you see it in action once, it will become intuitive. So let's see the score sheet in action. For this example, I'll be grading the reporter segment only. The opponent and reviewer segments are very similar. Note that you should grade all the teams in the match, not just one. When you listen to the presentation and the discussion, you can begin to mark out the responses. After a part of performance is completed, you can draw a horizontal line of best fit through all the points. This is essentially a visual average of all the entities. Wherever the line lands on the ruler is the partial score for this part of performance. For this example, the line landed on 4.9 and we rounded it to 5. We repeat the same process for the other two parts of performance. The reporter receives a mark of 2.2 for the discussion. It is rounded to 2. And for the answer to jury question, the reporter gets a negative 0.5. We write all the scores up in the partial score tally section up above. We perform an addition and round the final score to an integer. There are several things that I want to draw your attention to. Firstly, the answer to jury part of performance will only result in negative points. If the student's responses are satisfactory, he or she gets no points. Secondly, please do not forget to add the base score of 1 when adding up the partial scores. Lastly, your final score should be an integer from 1 to 10. Here are some general grading philosophies and grading recommendations. We would like to suggest that you give marks based on what a team did rather than punish them for what they didn't do. We always want to value solid physics rather than empty words. We would like to ask you to avoid handing out extreme grades in the first selective physics match. It is very likely that you will see stronger or weaker presentations in later physics matches. We would also ask that you remain consistent with yourself. You shouldn't adjust your grades to match that of other jurors in the room. It is only fair for the teams if you stay consistent with your own grade throughout the entire tournament. You can also customize the score sheet as you see fit. You can change the weights of certain entities to make the scores more reflective of the team's performance. Next, I'll summarize how the scores are computed for the teams. There will be 5 jurors grading every selective physics match and 10 jurors grading the final physics match. The raw score for one stage is calculated by averaging the highest and lowest grade first, then averaging this grade with the rest of the grades given. The raw score is then multiplied with the roll coefficient, which is 3 for the reporter, 2 for the opponent, and 1 for the reviewer. This is everything you need to know about judging in the CaYPT. Thank you so much for watching, and if you have any questions, please email us at CaYPT@stemfellowship.org.